Let us do a simple walkthrough of a case study on a RAG-based system. So the objective is to improve customer support efficiency and and quickly handle any customer queries in a call center. So we have a data of a large volume of questions and answers which customers have asked. So we are going to use that to reduce the long response time and decrease customer satisfaction. The goal was to implement a RAG-based solution to streamline all the customer response. So what we have in this model is a BERT-based model to fetch vast information from a database of support past documents. When a customer query is received, the retriever quickly identifies and ranks the most relevant cases. And what the generator does is based on the most matched response from the query, the GPT model generates contextually appropriate responses. This will help the customer service executive to generate quick responses. So what are the things we need to do? We need to create a data set of past customer interactions. You train the onboard-based model, and then you generate the responses using GPT-3 generator. You also do some validation using precision and recall. So this is a folder structure. You have a retriever model.py, you have generator model.py, you have a util, you have a customer interactions, and some other support documents. We will show a sample of how the customer. So your typical customer queries would be like this, and responses would be like this. So you will have a database of such questions and answers. So first, you have a class for retriever, which will use a BERT-based tokenizer. So what you will need to do is you have to convert this query into a embedding, and then based on the embeddings, you will generate the response. So token again, generator will have its own tokenizer, and then you will do the response. So these are some pre-processing steps. You have a main script. So basically, what you are doing is you are loading both the interactions and the supports, and you have to convert them into a so you have to convert them into a vector data embedding. So this is your typical interactions, some support documents. Okay, so this is typically how your response would be. Let me go through a code. So basically, you have these questions here, the responses. What you will do is you will first take those whatever questions and answers that you have, you will map them into an embedding. Then you will kind of put them in a fast database, which is a vector database, and then you create an app which will take the query and generate the embedding for the query, and then you will see what is the usage, and then you will generate precision and recall. So this is typically how you will do a very simple RAG based app. If you have any questions. So this is a typical example. So we take some new queries here. You pass it to the question, a RAG app. So this RAG app function will actually match your queries with a set of embeddings in the vector database. Once the retriever gets the most closest response, then you have the generator which will generate the response for your query. So what you see is for all your new questions, you generated results. So this is how you typically do inference on the. So this is a typical example. So we take some new queries here. You pass it to the question, a RAG app. So this RAG app function will actually match your queries with a set of embeddings in the vector database. once the retriever gets the most closest response, then you have the generator which will generate the response for your query. So what you see is for all your new questions, you've generated results. So this is how you typically do inference on the